Jai Hind to all. This is Chelsi Sen, Assistant Professor in IT Department, AKGEC, Ghaziabad. As we already discussed about the blockchain technology, and on that particular series, we are discussing about Introduction to the Blockchain Part 2. Here we are going to discuss various contents like what is blockchain, and we will be discussing about the double spending problem that comes in the blockchain. We are going to discuss about the blockchain architecture, how blockchain works, different components of the blockchain, different versions of a blockchain, layers of blockchain, and different pros and cons of a blockchain. These are the different advantages and the disadvantages of the blockchain we are going to discuss in this particular lecture. So just discussing about what is the blockchain, that is already we have discussed in our previous lecture that the blockchain is used for particular security reasons, integrity problem. It solves the problem of integrity and the double spending problem. So blockchain is defined as a series, a chain of blocks that contains the different informations, and it is a particular technique in which we are digitalizing the particular documents, and that is not possible to update and backdate particular data. Means we can't able to change that particular data. These are the tamper proof, where various terminology we have discussed in the blockchain technology, that is it is a distributed, it is decentralized, it is tampered proof, it solves the problem of integrity. So these are the various problems which is solved by the blockchain technology. The purpose of blockchain is to solve the double record problems without the need of a central server. Means it does not require the authority, a central authority. It is used for the secure transfer of items. These are the various applications which we have already discussed in the previous lectures. Like blockchain have the applications in the banking system, in the monetary system, in the land property system, and in the smart contract system. Means wherever we need the information to be confidential and that need not to be tampered, means that need not to be changed, so we require the blockchain over there. So the blockchain follows as the central decentralized method, means in which we don't have any centralized authority, means without required a third party intermediary, means we does not require any third party regulatory. We have already taken the example of the banking and or the government sector. Means in that particular organization we are having a third party. So in the blockchain we does not require the third party authority. Means for the authorization, the particular nodes and the participants of that particular nodes will follow that particular technology. So this is the particular term blockchain. Many of the people get confused between the terminology, that is Bitcoin and the blockchain. So just discuss about the things, the what is the Bitcoin and what is the blockchain. When some of the people used to say that the Bitcoin is same as the blockchain. So this is not like that. Bitcoin is not equals to the blockchain. So what is the blockchain is and what is the Bitcoin is? As we have already discussed that the blockchain is a technology on which we are storing different amount of information and which can't be able to change. So here we are using the particular technology blockchain, and in which we are having a concept of Bitcoin. What is the Bitcoin term is? So Bitcoin is a digital token which is used in the blockchain technology. Okay, so just get difference between what is the difference between Bitcoin and the blockchain. It is not equals to the blockchain. Blockchain is not a Bitcoin, but it is the technology behind the Bitcoin. Means the technology we are using, Bitcoin using, that is the blockchain. So what is the Bitcoin is? Bitcoin is the digital token which is used in the cryptocurrency. Hope you have heard about the term that the cryptocurrencies in the market. So the cryptocurrency is a cryptocurrency is the particular term which use the particular blockchain technology, and it is used in the blockchain technology for particular transfer of the particular amounts. Means we are transferring any amount, we are transferring any of the information, there we are using the particular transactions in the blockchain. So here the Bitcoin is a digital token which is used in the cryptocurrencies, and the blockchain is the ledger in which we used to keep the track of the particular digital tokens. Means of whatever transactions, whatever Bitcoin we are using, it keeps the track of that particular tokens. All the tokens details will be having the updated in that particular blockchain technology. So you can't have Bitcoin without the blockchain. Means if you don't use the blockchain technology, so you can't have the Bitcoin also. So Bitcoin is used in the particular blockchain technology. Means you can use the Bitcoin tokens in the blockchain technology, but you can use blockchain without having a Bitcoin. Mean in the blockchain we can have a different digital tokens, we can have a different digital cryptocurrencies. Bitcoin is not only the digital token which are used in the blockchain technology. So this is the particular difference between the blockchain and the Bitcoin, and these both the terms are not same, as the people get confused between these particular terms. So these are the different tokens. Bitcoin is the token and the blockchain is the technology behind the particular Bitcoin term. So now just discuss about the how the Bitcoin blockchain is solving the particular problems in the double spending problem, and what are the different components. So just discuss further about this particular terms. Double spending problem. The terms come double spending. What's the double spending is? As we know that the coin is a digital, means we have heard about the term that the digital coin, digital token means Bitcoin. So nowadays we are using a digital coins, digital currencies. Okay, so we can pass it to the multiple people. Normally in the traditional way, what we are having a coins or currencies in the physical format. So we can give to the one particular person, and we can't able to give the particular coin to the different person. But in the case of the digital currency system, in the case of a digitalization, the coin is digital. So I can pass this to the multiple people. Means I can pass to the one particular person, and I can pass to the particular next person also. So this is the particular coin which I can pass to the multiple people. So here we can take an example that give a copy to the Lisa and another friend for the another thing, and do the same linking to the all that. Means if I'm giving a one particular coin to the one person, and similarly if I'm having only one coin, what would be possible that I can give this particular coin to the another person. But in the digitalization process, it can be possible that we can give to the two particular people. So it could not be able to copy that particular, to cut and paste that particular thing. We have to solve that particular problem. This is called as the double spending problem. Means like if we had only one coin and it had given to the two people, in the real world it can't be possible, but in the digital world we can do that by using the cut and the paste method, or we can use the particular without the authorization and the authentication, we can do that particular thing. So this is what the double spending problems comes in the particular in the digitalization method. To solve this particular problem of double spending in the blockchain technology, we are having a centralized authority to monitor all the transactions. Means we are having a particular centralized authority. In this particular, we are having a centralized authority, and which we are having a ledgers. What the particular term ledger means? In which we are having all the details of the transactions, whatever the transaction we have done. Means for example, if I'm having a 100 rupees and which I have transferred to the one particular person, and then how it can be possible that I can transfer to the another person. So what the central authority does, if I'm having a 100 rupees, so it will keeps the track of a record that if I have transferred the 100 rupees to the one person, it will having a track of a particular record in the particular centralized authority. Means in which I'm having a ledger, and it keeps the transactions details that I have transferred these 100 rupees to this particular person. Now I'm not having a sufficient amount to transfer to the next person. Okay, for example, it will validate or verify the particular amount details. Means in that particular network, we will authorize the particular network. Okay, it won't be possible that if I have transferred the 100 rupees to this particular person, and now I will able to transfer this 100 rupees to the another person also. It won't be possible. So the central authority keeps the tracks of all the ledger records. Okay, so now how it would be possible that it can be possible that it can transfer to the both the persons. Now it keeps the tracks of both the people, how it would be transfer the particular amount. If I'm having a 100 rupees, I can transfer 50 rupees to the one person and the 50 rupees to the another person, and these all will be validated by the particular nodes and the particular networks. Okay, so this is how the blockchain works in the double spending problem. It will validate the transactions, that if, like in the banking, if you are having a sufficient amount, then only you would be able to transfer the particular amount. So it will authorize and authenticate this particular thing. So here the terms come authorization and the authentication, how the blockchain is working behind them and how it is solving the double spending problem. Means it is verifying the particular details, it is verifying the particular transactions. It cannot alterate or moderate the particular transaction details. So this is how the blockchain solving the double spending problem. Means it cannot transfer the single coin to the multiple peoples. Okay, so that's how the central authority monitors over here and the particular transactions work over here. And these particular lasers, whatever the lasers, we are having the information that this particular person have transferred this particular detail to the particular amount to the particular person. These transactions having a record in the particular laser. Laser is a term in which we are having a particular transfer of the particular details. So it will be it is there in the particular each node. Means each node have the particular laser, so that each person can verify and authorize this particular transaction. Now just discuss about the what is the blockchain architecture and how the blockchain architecture is there. Means how the blockchain is there, what is the series of a block. So how the terms comes in the mind, what is the blockchain architectures, what are the different components in the blockchain. So we will going to discuss about these particular things. So blockchain is a chain of blocks that contains the information and the data is stored in the inside a block and depend on the type of a blockchain. Means blockchain is a chain of blocks that contains the different information. For example, it is a Bitcoin. It contains the information about the sender, receiver, and the number of bitcoins to be transferred. Means whatever the information you are transferring, it is having the information in that particular block. Means if we are taking the example of a Bitcoin, so it would be having the information of the sender, means who have sent the particular amount, and who is going to receive the particular amount, and what are the number of amount or what are the number of transactions that we have transferred. So this is how the blockchain is stored the information. Means we are having a series of blocks, we are having a block 1, block 2, block 3, and these are the different series of blocks, and in which we are having the details of a sender, receiver, and the particular amount, number of bitcoins we are going to transfer. So all are the information are going to be kept in this particular block. Means we are having a different components in which we are having the hash value also, in which we are having a particular transaction details also. Like in the banking system, we are transferring any amount to the particular person, so it going to be have a detail of that particular amount also. Like we have taken the example of a land registry system or the land property system, so it going to be have information about that particular, that which particular person has sell the property to the which person. So all the details will be, all the information will be stored in the block, and it will be stored with the timestamp also. Means at which time that particular person have stored the information. So this is the series of a block in which we are having a information regarding to the particular technology. Like if we are taking the example of a Bitcoin, then it going to be have a information regarding the Bitcoin. If we are taking the example of a banking system, then we are having a detail of a transaction. So it depends upon the information what we are going to store in that particular technology. Now the first block of a blockchain is called as the Genesis block. Means the block in which we are having this is the first block, and this is called as the Genesis block. Means each new block in the chain is linked to the previous one. Means this is the block which is going to be linked over here with the block 1. Okay, so this is the first block and this is called as the Genesis block, and this is the block 2 which is going to be linked to the block 1. Means whatever linking is done using a hashing thing. So what the particular term hashing is there, so we are going to discuss in the further slides. So just discuss what is the block and what are the information stored in the block, and what each block having the particular information, means what each block contain. So each block has a data, means whatever the information we are going to stored in the particular block, that will be there in the particular block. Then the second term is hash. The particular hash is having some values, means it is the unique value which is going to generated by the different hashing algorithms that we will discuss in the further lectures, that how the hashing is generated, how the hash value is generated. As you all know that the hash value is generated by using a hashing algorithms like SHA-256, MD5. These are the different algorithms which generates the particular unique code of the particular to determine the uniqueness of the particular block. Now each block has the hash value of the previous block. Means, for example, if you are having a block 2, so whatever the hash value is there, it will contain the value of a previous hash also. Means, for example, this is the block 1 and we are having a value of hash is 2ZB1 and the previous hash is 000 because it is the first block and it will contain, it is called as the genesis block and it will contain the previous hash value is 000. Now coming to the next block, what would be it having? It would be having a value of a previous block. Means if we are talking about the previous hash value, so it is having a previous hash value of this particular block. So this is how the linking is done between the blocks and the blockchain technology. Means we are saying that it is a linking of a blocks. So how we are doing this linking? We are linking this particular technology using the hashing. Means we are having a value of the hash of a previous block hash. So now, for example, we are generating a different hash value over here and we are storing the value of a previous hash also. Like for example, here we have stored the particular values. So all the blocks contains the hash and the previous block hash value. This is the this makes the blockchain as a secure. We use this term that the blockchain is a very secured language. It is a very secure technology, and how the blockchain is secured. This is how the security is maintained. Means in between, if someone want to break this particular thing, it can't be able to done. Means if someone want to join the particular block in between, so it should have the value of the previous blocks also. So this is how the blockchain is making the particular technology is a secured. Block in a blockchain can have a particular details like this. We have already discussed that the hash of a block, which is a combination of alphanumerical details. Means like this we can have a combination of alphanumerical, means we can have the alphabets also and we can have the numericals also. It is a unique value which is generated using a particular hashing algorithm. So it is the alphanumerical number to identify the particular block. For the unique identiness, we are using the particular hash of a block. Then we are having a hash of a previous blocks. Then timestamp. What is the timestamp? Means at which time we have stored the information and which time we have linked the particular that block is added to the particular technology. So this is the particular timestamp in which we are noting a time or a particular duration of a particular block that is generated. The term comes as nonce. It is a random number used to vary the value of a hash. Means in nonce we are having a particular number is generated to verify the particular hash value. These are the different terms which we are going to discuss in more detail in the further slides. Then we are having a Merkle root or a Merkle tree, in which whatever the transactions we are there in the block, it is the hash of all that particular values. For example, we are having a multiple hashes. For example, we are having a 10 hashes value, means 10 transaction we are having. So all the 10 transaction we are going to generate the one hash value. Further of hashes of the hash, means hash of all that hash value will be generated through this Merkle root tree. So this is how the blockchain block in a blockchain have stored the particular values, and it can have the particular transaction data. It contains the detail of several transactions. Means if A is transferred 100 rupees to the B, so whatever transactions is done, it contains the detail of that all the transactions. Now talking about the authorization and authentication, how the blockchain works, what are the process behind the blockchain, we are going to discuss about that particular thing. So just discuss about the how blockchain technology works. Like in the digital world, we are having how we can identify the particular terms that it is the valid thing, it is whatever the transaction is done is authorized, it is means done by the particular person only. So these two terms comes under the blockchain technology, authorization and the authentication. And the authentication is done using by the cryptography, by using the different public key or the private key. Means authentication, if you are using about the proof of identity, so authentication is done by using the public key. But in the authorization, we are using the different we are using the cryptography, in which it involves the public key and the private key, and it is created using a public and private using the complex algorithm. Cryptography, we have already discussed that how cryptography is used, how the cryptography solves the problems of a data transformation. It doesn't moderate the particular information in between the transaction. So this is how the cryptography is used in the blockchain. It is a very important, cryptography plays a very important role in the blockchain. So it uses both the public key and the private key for the signing in, for the authorization, for the authentication, and for the verification of the particular transaction. Now, blockchain technology works like that the private key must be maintained the confidential. Means that we already know that the private key should be maintained confidential. Then the public key may be distributed to the anyone in the particular network. We are having a series of a network, we are having a different nodes, as we already have discussed that the blockchain is in the distributed network, it having a peer-to-peer network in which we are having all the identical copies to the each nodes. Means we, for example, we are having a different nodes, and these all the copies of a ledger are distributed to the each node. So how it guarantee the authenticity of the data, how it ensures that the data will not be tampered with within the transit. So this guarantee by using the digital signature. This term also we have already discussed in the system security, CSS, we have discussed. Means digital signature is used in the cryptography process, which provides us the validation and authentication in the same way the signature do, but in the digital form. Like for example, in the real world, we are having a different sorry, in the real world we are having a different documents and on which we used to sign. So it will, what's the use of the particular signature? It validates that this particular person have done the particular task. So to authorize or to validate that particular person, we use the signature. Over here also we are using the digital signature. It ensures the authenticity of the data. It ensures the particular validation of that particular person. So it is comprises of generally three parts, like generation of public and the private key, signing algorithm, and the verification algorithm. So digital signature, generation of a public and the private key. How we can generate the public and the private key? We can use the RSA algorithm, in which we can generate the public key of the particular public and the private key, and from that we can use the transaction at the particular that time. Means the cryptography in the blockchain ensures the security of the transaction. Means whatever the transaction is done, it stores the timestamp, it stores the transaction unique ID, it maintains the security of that particular transaction by using the public and the private key, which we have generated by using the particular algorithm. Now then comes the signing algorithm. So what signing algorithm does, it maintains the integrity of the data. Means whatever information we have sent to the particular person, for example, I have sent any message to the particular person, so whatever information I have sent, that only the particular person should receive. So it maintains the integrity of the data and certify that this information is correct no moderation, no alteration is done in between. So how the particular person can verify that particular thing? So we are having a verification algorithm in which in that process the reviewer can verify the authenticity and the integrity of the message received. Now the blockchain, how the blockchain works, it can record in the, it maintains the immutability of the particular transaction also. It can use the encryption, the decryption of the particular digital signature. Means we are using the encryption technology. Encryption does means it does not, it maintains the authenticity, integrity and the security of the data. So what the all blockchain works means, all the nodes, all the peers we are having a each identical copy of the database to the each node. Means if we are having a 4 nodes, so all the 4 nodes will be having the identical copy of that particular databases. Means any alteration, any modification is doing in the first node, so all the node will be reflected, means all the modification will be reflected to the all nodes. So this is how the blockchain technology works. In the next lecture, we are going to discuss about the different components of the blockchain. Till that, thank you.